Hello students, today we'll be discussing urban ecosystem services. In this particular module, you have seen that we have discussed the ecosystem services and its concepts evolution. We have also discussed different types of ecosystem services like provisioning, regulating, cultural and supporting. Followed by that, in last two classes, we have discussed the ecosystem service evaluation from the biophysical, economic, socio-cultural, as well as the integrated valuation methods. And we have discussed in each and every types some models in detail so that we get an idea how the evaluation happens and what are the input, what are the processes and what we get out of those exercises. So, in today's class, we will be discussing very specific urban ecosystem services and we will identify the traits which brings these services within the urban ecosystem. For that, we will be discussing process, methods, techniques at different spatial scales like neighborhood, city, regional scales. And we will also pick up different type of ecosystems like it can be corridor, it can be patches, matrix, networks. Let us see meso, micro, different scales we will be discussing through the examples. Ecosystem services, if you all of us we remember that they are the direct and indirect contributions of ecosystems to human well-being. They support directly or indirectly our survival and quality of life. So, the same thing you can find in this particular image where the ecosystem is at the center, land, freshwater, ocean, atmosphere, the components are there and we are getting different type of services like provisioning and regulating and these are helping the human beings. This well-being is not only well-being, I think you remember we talked about very direct word that was a benefit. So we discuss that how this ecosystem functions are providing the services which will help our economy and at the same time all our activities which is related to the economy and other things are impacting the nature. So that's the way we talk about the urban ecosystem. And I think we remember all four ecosystem service type: provisioning, regulating, cultural, supporting and habitat. Now let us have also a recap discussion shift from natural to urban ecosystem services. Urban ecosystems, as we understand, they differ from the natural ecosystems because we have added the built structure, we have modified the landscape, and intense human pressure that is on the urban ecosystem. Definitely, that will bring changes in the ecological patterns, functions, and flows. Ecosystem services in cities, they arise from complex socio-ecological systems rather than from purely natural environments, which we have discussed at the very beginning of this course. Now let us see the urban ecosystem traits. Urban ecosystem influences ecosystem services and they have distinct traits. Some of them I have jotted down. First one we can remember that is fragmented and artificial landscapes. The cities contain small and disconnected green patches such as streets, lawns, parks, rooftops, surrounded by built infrastructure. These fragmented patches limit ecological continuity and reduce the natural capacity of ecosystem to supply the services. So fragmentation becomes a very strong criteria. Very high impervious surface because we keep on changing the surfaces like 40 to 80% impervious cover we bring in the urban ecosystem which influences the infiltration, increases the runoff and it also alters hydrological services which you can compare easily with natural ecosystem and we can see the differences. Then altered hydrology, climate and pollution cycles which we have discussed at length like heat island, evapotranspiration is getting modified, river channels are modified, and air pollution are getting created, water layer is going down. So water purification, temperature, air filtration services, they get affected. Next one we will be discussing, that is the very high demand on the ecosystem services due to the concentrated population density. They are having extreme pressure on limited natural spaces. Even a small park may serve thousands of residents. Urban ecosystems therefore face a strong demand and supply imbalance. It happens in every different type of natural facilities. Faster and more variable responses to disturbance. Urban ecosystem respond quickly to pollution, heat waves, intense storms, and daily human activities. Services such as cooling, air filtration, and stormwater retention, they can change this rapidity, and continuously we need to manage them. The next trait which we are going to discuss, that is the engineered and the natural interactions that shape service delivery. So most of the services which you can find in the cities, they emerge from a co-shared, engineered as well as natural processes, ecological processes like constructed wetlands, green roofs, rain gardens. So they are very good example of this combination of engineered and natural interactions. So it's a combo. The last point which we'll be discussing, that is the strong influence of social and institutional factors. Urban services depend on governance, public preferences, land regulation, income level, and cultural values. Only due to the governance, probably we can always cite Singapore today as a very good example for urban ecosystem understanding. Cultural services such as recreation, mental well being, and place identity are especially important in cities. Now, we'll be drawing a parallel between ecosystem service evaluation methods and ecosystem service mapping. If you remember, in last class only, we have discussed this ecosystem service evaluation. We talked about biophysical or ecological valuation, economic or monetary, socio-cultural, where we have tried to understand the participation from the community, and integrated, where all three are there. So that was the evaluation parts. Now we will talk about the ecosystem service mapping. Why this mapping is important? Because ecosystem services are spatially uneven. Cooling, flood regulation, biodiversity support, or recreation, or any other ecosystem services, you remember, you just try to observe that they don't occur uniformly. So, space, over the spaces, they are distributed and there is the variety. So, mapping ecosystem services at different spatial scales like neighborhood, city, and regional scale becomes imperative. And obviously, advanced tools and techniques, they always helped us to think more for the future. So now we can not only map them, we can analyze them also. And these evaluation methods, which we have discussed in previous lectures, that helps them to be analyzed and being numbers into it. So let us now talk about this mapping of ecosystem service at neighborhood, city, and regional scale. At the neighborhood or street scale, that's a fine scale, micro scale, captures micro variations, tree canopy, shade islands, small wetlands that you can capture. The services, what we try to understand, that is shading, thermal comfort, walkability, noise reduction, local air filtration. So these are the ecosystem service from this scale. In the city scale mapping, similarly, which reveals the broader gradients like UHI, watershed functions, air pollution corridors, and the type of services it offers, like stormwater management, carbon sequestration, recreation networks. These are the services which we can map. At the regional scale, which shows ecological networks, watersheds, and supply demand mismatches, that we can map. And what are the different type of services we can map? That is the water supply, biodiversity corridors, climate regulation, food provisioning. So that's the way spatial scale as well as our mapping intent and the techniques, they vary. So we'll be discussing some of this through examples at different scale like neighborhood, city scale, which will be a matrix wetland. City-wide scale, there we'll be discussing the network. And also in regional scale, we will have two different examples. We can discuss the green belt, peri-urban forest, upstream, downstream. We can discuss several things here. So the techniques, evaluation process, which are going to help to evaluate the relevant services, it brings visibility. This mapping brings visibility. We can talk to the decision makers. Policy, planning process, they can actually take advantage of this integration. Neighborhood scale, the street trees providing microclimate regulation, that we will be discussing as an example. Regulating service, it's a tree microclimate regulation. So the ecosystem service providers are the cooling, shading as well as the evapotranspiration. Both the processes are going to be utilized by the trees. Air quality improvement, noise reduction. What we can map? Tree canopy cover from high resolution satellite image, NDVI maps, land surface temperature maps, tree inventory maps by municipal agencies or any other agencies. I will share one good example with you that is from Bangalore, and this particular study has aimed urban tree cover mapping where global products underestimate scattered and roadside trees. So here we will see that how improved techniques are being used to understand that particular scale better so that ecosystem services can be identified better and accordingly the ESS evaluation can improve. So the study area was 5 by 50 high resolution worldview 3 that was used for fractional tree cover for training and Landsat 8 as the predictor. So that's the comparison which has been done in this particular study. The particular source has been given, so you can go through this particular paper and you can read it by yourself. Method multi-layer perception predicting continuous tree cover for each 30-meter pixel that was being used. And what the result is? 13% almost. That was the error from the method 1 to method 2, global versus this local one. So the tree canopy product, especially for solitary and street trees, 13% means a lot. So you can see in this particular image that this is that global 30-meter Landsat tree canopy version. It's only showing one very direct patches. The others are not really visible. Whereas when this Landsat tree cover is being used, you can see that so many green patches are actually been mapped. And that's the way it has been a improved scenario for the ESS mapping, because now you see that it's not impervious layers. It's actually having the trees there, so you can go for the microclimate regulation analysis with much better set of data. So it will influence your heat island mitigation, carbon storage calculation, air quality buffering. All these aspects will get covered. The next example we'll be discussing, that is at the city scale. As I said, it's going to be a matrix, that's the urban wetland. So we'll be discussing from the lens of regulating and supporting services. Any urban wetland, the type of services it provides are the flood mitigation, groundwater recharge, nutrient cycling, and biodiversity habitat provision. What can be mapped in these particular cases, type of cases? That is watershed boundaries, storage capacity models, flood inundation maps, land use change around the wetland. So this is that example from Kolkata wetland, and this particular study has gone for three different pockets: Shudhane Khali, Goshaba, East Kolkata wetland. So these are the three which has been shown here. The method has been used, that is structured lit review on ecosystem services for these wetlands, so that to understand what is the normal condition at present was the condition. Field observations plus stakeholder dialogues were added to the method, and rapid assessment of wetland ecosystem services. It's a Ramsar adopted tool. It scored 36 ecosystem across sites and benefit scales using this particular tool, RAWES, ROWES. What are the findings? That only a small subset of services at each site it used to be published in the existing literature. Whereas using this RAWES, 32 to 36 ecosystem services have been identified. So you can easily understand from 10, 12, it's now going to 32, 36. So from more than one sites, not only one site. So that way it became a very good proof that if we can map it better, then our ecosystem services identification as well as its evaluation will improve. So that's the way this particular graphs were being shown. You can study these two graphs very carefully. It is talking about different type of ecosystem services: provisioning, regulating, cultural, supporting, and on the y-axis you will find different spots, and in each spot all these services have been mapped, and that has been presented, and then through a scoring system it has been brought to an averaged one. Thus the black one, all services. And here we can see a tangible change into this capturing of ecosystem services. And these ecosystem services are actually having significance beyond the local space where they are. It's not only local scale, it is going for the catchment, national, as well as global scale. So you just imagine the services they are offering that is having significance at so different scales, including the global scale. So they are very important to be understood, to be mapped, to be really documented and evaluated, so that people start recognizing their values and accordingly plan any changes. So these peri-urban wetlands like East Kolkata, as I was telling you, it provides us many different type of services: wastewater treatment, food production, flood regulation, biodiversity habitat, and the cultural values. But mostly they are not really having formal evidence, and planning is not integrating them. So this ESS is very important to be mapped and evaluated. Using a structured ESS tool like RAWES provided a systemic, spatially comparable, and as well as peer accepted overview of multi benefit wetland systems. And that highlights how management stress, encroachment, intensification, protection changes the bundle and scale of ESS delivered. Our next example will be city-wide scale. Cultural services, we will look at recreation, mental health, aesthetic value, and the social interaction. What can be mapped? Many things, including the green network connectivity, park accessibility, user density or mobility data, blue-green corridor models, riverside parks and lakes, etc. So the example has been chosen from Singapore, Bishan Ang Mo Keo Park. Cultural ecosystem services and cultural ecosystem benefits. Both the things they have actually redefined through this exercise, and it has been used for the entire city of Singapore. I'll be showing you this particular image. You can see that there is the central area here, and all the parks are connected through this green, and the coast to coast trail is here. So that's the way it has been tried to capture both the cultural ecosystem services as well as ecosystem benefit concept. And cultural ecosystem services arise when people engage in cultural practices. Only providing the ecosystem doesn't make it a cultural asset. When they use it, then their values, they shape how that particular cultural ecosystem benefit or services will be co-produced, and that reshape those values in a continuous feedback loop. The method used, online public participation GIS, PPGIS. So park users mapped places they value and described activities or feelings like relaxing, socializing, exercising. That type of information was collected online. And social media text mining, like extracted keywords, Google reviews, and sentiments related to cultural benefits. All these texts were mined appropriately. So, use of tools and techniques are very important to understand this city urban ecosystem services. Key findings: hotspots of recreation, aesthetic enjoyment, natural experience, and social interaction cluster along the water and key park features. That I will explain again. I will show you that image again. These maps clearly distinguish where cultural services are generated and which types are dominating in each zone, like quiet edges or active plazas. Now, let's see, you can read this, all the cultural ecosystem services, and you can read through this image: social, relaxation, biodiversity, recreation, aesthetic, and education, and how it has been evaluated through the indexing system. Similarly, you can also go for this one where it has been also linked CES with the benefit. So, this particular ecosystem mapping process has actually brought the prove the relevance that city agencies can really use PPGIS and online reviews to map cultural ESS at city scale beyond just biophysical indicators. And this provides actionable inputs. Which park segment needs better access, more shade, quieter spaces, that type of remarks you get. So that directly helps in improving the planning. The next scale which we will be discussing, that is the regional or metropolitan scale. And regulating services, primarily we will be discussing carbon sequestration, windbreaks, air quality buffering. And through these scale, and at this scale, what we can map, that is definitely ecosystem services, land cover maps, biomass, air quality dispersal models, regional wind flow mapping. So those are the different type of maps are being used for this scale. The first example I will bring from Cape Town: provisioning, regulating, supporting, and cultural, that very fundamental ecosystem services, how that has been mapped. It is a old exercise, 2013, and you can see the potential is full 100% for each one of it, which are in this particular case, it was everything related to uh, it was related to grazing, flood mitigation, soil, critical infiltration, coastal zone protection, groundwater recharge, groundwater yield, groundwater quality, and land capability. And 100% potential to the current scenario and where they would like to be at future. So that was there. That had been assessed. And how it has been assessed? It has been assessed through identifying the ecosystem types and relevant production units and key interactions, spillover effects, which will add some additional benefits. and where we are having the restoration potential. And the same exercise was done for the provisioning services like food, crop production, livestock production, freshwater fish harvest, seafood harvest, medicinal and ornamental resources. Also the fuel wood as well as the fiber harvest. For the regulating services, we see that water purification, water filtration, soil retention, carbon sequestration, these were being mapped against the production unit, key interactions, spillover effects, and restoration potential. Some more regulating services like flood control, coastal storm protection, noise reduction, and nitrogen retention. These were being mapped for this Cape Town city. For the supporting service, which we say generally habitat and supporting, so habitat provision and primary production, soil formation and nutrient cycle, these were mapped. And lastly, the cultural services that was mapped like recreation, cognitive development, aesthetic benefits, health benefits, as well as the tourism, educational opportunities, cultural identity, and rituals. So that's the way for the Cape Town case, we can see that very basics. Before even using the tools and techniques, you need the framework. So, how to really map it, that has been identified. So, you can learn that how to start the mapping. You go for the service type, you are identifying, go for their units, interactions, and try to understand if you need the spillover effect and restoration. Then you come back to those evaluation processes which we have discussed in the previous class. And then you can also go for several different type of techniques which are required for your individual matrix patch and corridor scale items. So now we'll be going for another case study at that scale only, urban peri-urban, but in this case it's a forest that has been mapped for the municipality. The estimated green cover and key regulating ecosystem services. That was actually the key aim for this particular project to be mapped. And what they use the method of eye-tree canopy and random sampling they have done to classify the surface covers and monetize that ecosystem services. That's the calculation they have utilized. So the land cover composition came like grass or herbs like 38.7%, quite high. Trees and shrubs have 29% almost. Impervious surfaces at 21%. Soil and water also those were being identified. How this can help the city? In the Georgia, Tbilisi is the capital. So we can see in this particular case, all this mapping has helped them to quantify ecosystem services like regulating one, air pollutant removal. So how many tons are getting removed every year? And also spatially, how many tons for each square kilometer area. So both the sides, spatial as well as by virtue of absolute number that they have identified from through this mapping system. Annual carbon sequestration that was being done, and that was also brought at the money stage, that was also valued with the monetary value. We can see huge, that is 8.22 million is a huge amount of money. Actually, that type of service the city is getting from this urban and peri-urban forests. Carbon storage in trees and shrubs, that was also being quantified, as well as the estimated value came in a money form. So these are how this mapping is relevant for ESS as well as the planning. First, citywide ecosystem services valuation of the Tbilisi urban and peri-urban forest. It actually showed them as a major green lung that they have already. So that provides the strength that how to really go forward. So the long term carbon stocks they could identify where they have. And this mapping also provides spatially explicit arguments, per square kilometer values, cover maps, etc., to integrate green infrastructure into metropolitan planning. Climate resilience and air quality policies will get benefit of it normally. So today what we have discussed the natural to the urban ecosystem services that shift, and we have also discussed the urban ecosystem services and its different traits. Then we have come to the next segment of discussion that was primarily on mapping. How to map this urban ecosystem, the spatial one, spatially. Because in the previous classes, we have already learned the evaluation process. But as spatially it is having heterogeneity. So we have to learn how to really do it. So some of the examples I brought in front of you so that you can explore further and you can understand that at any scale you have to understand that for which purpose you are doing that and what type of ecosystem services that particular scale is trying to offer, where your attention shall be. So once that is clear, then it is easy for you to choose the tools and techniques, methodologies, frameworks, and ultimately either you can show through spatial maps or you can quantify, and that's the way we go forward. So I believe all these case studies you will go through once again and you will be able to understand the significance of them. So these are the references. Thank you.